So, for this video, we are going to talk about vertical shifting. The bane of vocalists everywhere, the dreaded auto-tune. Now, a vertical shift is going to take this sine or cosine wave and vertically move it up or down without changing its speed. And it's going to be denoted by this letter D on either of these equations, and sometimes you would see that as a beta in some textbooks. So let's talk about autotune for a moment. You're probably familiar with autotune if you listen to pop music. It's a computer-aided singing device that will correct your note that you're singing, and will do so through computer synthesis, which is going to make your voice sound more like a robot and more artificial the further you are off from the desired note. This was made famous by Cher in Believe, and also made infamous by a lot of pop singers who just can't hit those notes well, and most music critics are kind of savvy enough to realize, hey, you're not really a good singer, you're just got a really great producer. And again, autotune has its place where it's intentional, as some artists have used intentional auto-tuning to wonderful effect, and also disastrous use of auto-tuning in live concerts. But just to give you an idea what we mean by auto-tune, if you're not familiar with the topic, imagine me singing the high, medium, low, medium, high, but instead of singing it like I should, like high, medium, low, medium, high, that's for cosine. Instead of me doing that, I sang it as one note. High, medium, low, medium, high. Now what the computer would do is it would synthesize the high and the low so it would be correct, but it would do so in kind of a computery sounded way, like high, medium, low, medium, high. So it would do so and it would sound, weird. Again, I strongly recommend you seek out some good and bad autotune just by Googling some of that fun stuff there. But please don't get down that rabbit hole too far, because we got a lot of trig to do here. We are going to be doing our vertical shifting using our sine and cosine waves. Now, I am going to also throw in the concept of amplitude, and I'm going to do so just because you can better see that if we kind of do this. And so I've got two graphs here. On one graph, I'm going to write down my y equals 3 cosine x, and on the other graph, I'm going to go to y equals 3 cosine x plus 2. I'm going to show you the effect of auto-tuning. So let me take my amplitude, which is 3. So that's going to change my amplitude instead of from a 1 to a -1, a 3 to a -3. And a cosine wave is, whoops, I almost screwed that up. High, medium, low, medium, high. There we go. Probably could have used some auto-tuning on my own tune. And that's one period here, and we're going to go high, medium, low, medium, high. And here's the next wave. Okay, so this is the graph, and I'm going to write down y equals 3 cosine of x. We haven't put the +2 on it yet. Couple things is that we have a 0 as our x-axis, and we have 2 tick marks going from 0 to 3, and 2 tick marks going from 0 to -3. So, what is our amplitude here? We always report amplitude as an absolute value, so our amplitude is 3. The period goes to 2 pi, just like normal. Our vertical shift, now we haven't actually done the vertical shift yet, so we can't actually answer these two things. So what I'm going to do is I'm going to copy the picture over here again. High, medium, low, medium, high, medium, low, medium, high. Come on. Don't screw on me here. There we go. Alright. Okay, so I have this, and I have my 2 pi right there. So everything's looking great. Now, what I'm going to do is I'm going to change these values. Instead of from 3, 0, and -3, I'm going to move it up 2 according to my vertical shift. So now this is 5, and this is going to be 2, and this is going to be -1. Okay, now you probably had an instructor before me, maybe in a trig class, say, okay, now write the whole thing, but then shift everything up too. I find this method's a lot better, and I find it's better just because you can, if you'd like to, put in a brand new x-axis if you want to, because that would be about here. And some people now get confused because they say, like, well, the y-axis is dropped. That shouldn't happen here. No, it literally should, because if you're taking the whole function and moving it up too, it's like taking the function and getting it out of the water. If it was halfway in here at 0, then it would be more 2 units out of the water here. So our vertical shifting was 2. You could put a plus here if you'd like, but we don't usually write a plus in front of positive numbers. But now we're going to talk about something called the midline. Now the midline is the line that cuts through the middle of our periodic function. So midline definition is going to be bisecting the function with a horizontal line. All right, trying to write fast here. Sorry if my handwriting's bad. I'll read again. You're bisecting, bisecting, the function, fun, function, with a horizontal line. That horizontal line is right here at the 2, right here. That's where your horizontal line is. And this red line is the midline. Now, you see what cool thing that I have just done by not shifting the high, medium, low, medium, high off of its original axis and change my y-axis? It's so easy to find the midline. The midline is now at 2, but you have to write the midline as a function. Now on XYZ homework, they'll give you the y equals, but on my tests, ladies and gentlemen, you gotta put in your y equals here. The midline is a line, not a number value. It is actually an equation with y equals 2 being that midline. Let's do another example, but let's throw some more stuff in. Let's do an example that has amplitude, vertical shift, and a period adjustment. Ooh, this will be good. All right, check this out here. Now we're going to have to deal with amplitude and period first, and then we'll deal with vertical shift. And that's why I've got 2 pictures of this on this worksheet here, just because I'm going to want to spend one of my pictures kind of getting my rough draft, and then on the other picture I have my final copy. So let's go and talk about this. This left-hand side is going to be the equation y equals -4 sine of pi over 2x. Now, if you did not watch the previous video where I talked about changing periods, you're going to want to do that. That's a really informative video, and we're going to talk about 4 and -4 for my amplitude. So there it is. My amplitude always is reported as an absolute value. Think of the absolute value of A right there, and the absolute value of -4 is 4. This obviously changes the way that the sine wave moves, because instead of starting at 0 and going up, it starts at 0 and goes down. So it goes medium, low, medium, high, medium. Okay, and that's one period. Now, what I'm not going to do is put 2 pi here, because that is not going to be my period, because we have this letter B in front of this equation x that's going to change the period. And I'm going to show you both methods of how to deal with that, either what if you want to do with the period, or if you want to use the gap method. So let's do the book definition first, which is 2 pi to find my period here. 2 pi divided, oh shoot, that isn't an absolute value. That's silly. The 2 pi is in the numerator, so 2 pi divided by the absolute value of pi divided by 2. So we're going to skip flip multiply, so this gets changed to 2 pi times 2 over pi, because that is skipping the 2 pi, flipping the pi over 2, and now what we get to do is cross off the pi's. 2 times 2 is 4. My period is 4. I can put a 4 right there, and now I can show you the gap method. Again, the gap method may have been where you started from, because pi over 2 is the gap in this x-axis for sine and cosine. So then we multiply this by 1 over our pi over 2. And then if I change that, this is pi over 2 times 2 over pi. And pi over 2 times 2 over pi is 2 pi over 2 pi, which is 1. So my gap is 1, which you could have easily figured out if you took your period and divided it by 4. So it goes 1 through 8 very easily, and that's pretty nice. So that was a review of doing the amplitude, this case a negative amplitude, and a period, this case a period that happened to be in radians. Okay, so now let's take care of the vertical shift. So we can copy everything from the previous picture here, so I will do so in blue. We got our medium, low, medium, high, medium, low, medium, high, medium. Okay, so there we go. There we go, go. All right, now, that could have been better there. Okay, so we got our 1, 2, 3, 4, 5, 6, 7, and 8. So now what we're going to do is we're going to change our 4, 0, and negative 4. We're going to change that by going down 2. So this is 2, negative 2, and negative 6. So now that we're a 2 to negative 2, negative 6, our vertical shift was negative 2, and we would put a negative in front of that. And our midline is going to be that horizontal line right there that cuts or bisects that periodic function in two, into a northern part and a southern part, and this is going to be y equals negative 2. That's my midline. So if you're curious if the vertical shift is always going to be the same numeric value as the midline, yep, that's pretty much going to be it. So don't forget your y equals though, because on my tests, I'm going to require it. So for our final part of this video, we're going to do one more example. And in this case, the period is going to be not as nice as whole numbers here, but we are going to mess with the amplitude. We are going to change the period, and we're all going to do vertical shifts. And our last example coming up now. So for this problem, we are going to start off with, just like we did in the other problem, start off with adjusting the amplitude and the period in the first graph, and then for our second graph, we are going to mess with the vertical shift. So our first graph is going to be y equals 3 cosine of 1/2 x, and so let's get our amplitude, 3 and negative 3, and we can put our answer in here. Cosine is high, medium, low, medium, high, medium, low, medium, high. So here we go. Here we go, go. Making it work. Okay, so there we have our problem, and we're not going to write in our period as 2 pi. Let's use the period method, which is 2 pi divided by our 1/2. Skip, flip, and multiply. This makes 2 pi times 2 over 1, so 4 pi is our period. Now you could divide that by 4, or if you use the gap method where you took pi over 2, oh, come back, buddy. Come back. Uh-oh, looks like I lost my function. All right. Cool. You can take your pi over 2, and then you can multiply that by 1 over b, which is 1 over 1/2, which I'm going to change to pi over 2 times 2 over 1, which is equal to pi. Which, again, you probably could have easily figured out if you divided the 4 pi by 4. This is pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and 8 pi. All right, super. How's that looking? Now, all you need to do for the final picture is adjust the vertical part. Oh, I should probably put down my period there as 4 pi. That is the distance between here to one complete period of my periodic function. So, here we go. We're going to take our 3 and we're going to make that a 5. Take the 0 and make that a 2. And take that as a negative 1. Now, some of you are thinking like, but Anderson, couldn't I just take my eraser over here and go wipe, and then go 5 to negative 1 and be done? Now I actually have my plus 2, and it's like, yeah, you can totally do that. Save yourself rewriting the problem here, which is seriously going to cut some minutes off the time of my video here. So yeah, you got it. That is exactly your answer here. Let's fill this out. Our vertical shift is going to be plus 2, which we would write as 2, all right? Don't put the plus in front of that. That's silly. And then the midline is going to be y equals 2, because this is the line that bisects this in half into a northern half and a southern half. And that, my friends, is the vertical shifting. All right, so I beg you to stay tuned to the next video where we're going to throw all three of these motions together with a fourth motion called horizontal shifting. So thank you again for watching and putting this all together. I appreciate your time and effort.